Welcome to a new test and teardown video. This time it's a switch mode power supply, a 1 kilowatt unit, and it's a Sorensen. Oh, let's get a little bit of light here. A Sorensen DCS40-25E. So this unit can do 0 to 40 volts, 0 to 25 amps. If it works. Multi-turn pot meters. Nice digital LED readout here on the front. It looks a little bit like it was dropped on the floor or was kind of rack mounted a few times. This kind of thin, flimsy plastic glued on top of aluminium brackets and plates, and then screw this into racks. I mean, this is not a good way to do it. Please. It's going to look ugly real fast. So it's only a 1 unit height, but full depth unit. Super flat, obviously. This is what it's designed to do. Oh, it is quite heavy. We got some really massive output terminals right here, where you can screw in some really big fat, but it's only 25 amps, so I don't know why the big thing about that. Mains supply, a little bit flimsy wire here. I think it's also possible to click on some sort of a plastic isolator here, but it's obviously not mounted. Analog remote. It is connected, as far as I can see, local to the front plate pot meters, but if you open this, you can just remote this as well. So I heard rumors about this should work, so it's probably going to be a boring power-up sequence. I was hoping for a little bit boring here, because I really don't want this to blow up. Okay, let's do it. Mains applied 0.5 watts idle. $27 watts of idle power consumption. We're in voltage mode. And we got response. And if I crank this down, we go to current mode. So that means current mode goes all the way to 0, and it's not a fold back, it will return. So let's just give this a tiny little bit of current here. No other LEDs or anything here. There's a little bit of leakage. It is not proper grounded, so I will do that before I connect this to anything else. We have now learned to take a little bit more care of our instruments here, so let's test a little bit here. Let's crank this up to 40. And here is the thing about this. Is a classic problem, or just how they do the DCS series from Sorensen. They all do this, and I kind of know this because this is not my first. And output voltage and idle power consumption. Look at that. 55 watts at 40 volts output. And at 0 volts output, 25 watts of idle power. So you can imagine what happens if you got one that can do 80 volts of output, which I actually also own, and it can just do double the current. So you can imagine the size of that thing, and you can also imagine the idle power is crazy high. And this has something to do with snubbers. I look forward to open this and prove if that is also the case. But now I will try and perform a little bit of a load test. So we are loading a little bit. 40 volts and 4.9 amps. It is actually, if you look at both of them, so this is about 200 watts of output, wouldn't you say? I tried to adjust both of my loads for 100 watts each. I think they can do much more than this, but this is just a first little try. And then I measure at the same time the input power is 258. And if we look at this, the idle power was 55. I mean, isn't that a little bit amazing? That, I mean, if you look at the efficiency of this converter, if we remove the idle power from the equation, I mean, this is as close to a 100% efficiency as you can probably get. That is crazy. That's what I'm saying. And at 200 watts output, this is the output ripple. It's like 20 millivolts per peak here. And I set the probe for 20 megahertz bandwidth. So it's this is 50 kilohertz, by the way, the spike to spike time. So I guess that is what is running, but it's really low ripple. I mean, let's go and look inside, right? I wanted to document the idle power loss, and so I'm just browsing around in this unit, and immediately I see something we totally need to address immediately. See those resistors, the big ones right there, right? To the right of that resistor there is a little orange capacitor, and that capacitor is 100 degrees hot. So I need to go and fix this immediately before it blows up. So that is why a thermal camera is a lifesaver. Look at your equipment with a thermal, idle, under load, figuring out if the stuff that gets hot is the stuff that is supposed to get hot. I mean, this can't be good to have a capacitor here that is running that hot. This needs to be fixed immediately before we can proceed. Normally with Sorensen power supplies, the snubbers, they run so crazy hot, and I like to see if that is also a case in this one. Also in this one, the primary capacitors, that's the rectifier and the primary system here, those resistors here, they run very hot. I mean, why do you need to discharge those capacitors that violently or that fast? This can't be good. I expect this to be the voltage selection, how you do that, right? So that will be mains input. We got ourselves a really nice filter, and then we go to the input protection fuse, and then we go right here, right? What is that? A filter of some sort, right? I can't really see exactly what that is. I don't want to touch anything here because I just powered this off. So I always wait a few minutes before I start poking around with stuff. But that one, I want to see what that is. And then of course that is a relay. Some other resistors. That got to be the bridge rectifier, right? And another fuse that is also very normal to Sorensen to have another fuse to the secondary side. And if I'm not mistaken, we got ourselves a full bridge switch, and that will be all the rectifiers. That's probably just normal diodes. They don't really like to do it with active field effect transistors and such. And I see again, this was the very, very hot capacitor, but I see again the same kind of capacitors used here. So that is a little warning sign. The resistors around here also gets very, very hot, and I don't know yet what they are doing. I guess that is the output current sense. And then we got ourselves output. So yeah, output capacitors. And what is that? A funny diode standing up here. I also see something that is a little bit worrying. A little bit of a funny repair here. So this looks like a track was melted. So somebody connected something they shouldn't to some of the programming inputs here, and then oops, fried a track here. So it was indeed blown up and serviced, and it looks like it is working so far. So I removed the orange capacitor. This is the primary side of the main transformer. Underneath this PCB we got two wires, as you can see here, the primary windings, okay? So that is the capacitor, and then it's connected to 3 resistors in parallels, and they are 155 ohms in total. The other side of those resistors, they're connected to that point, and goes to the half of the sides of the H bridge, the A and the B. That's connected to each side of the primary side, right? And then there's a current transformer to pick up the primary current. So they're really snubbing super hardcore here. But of course this capacitor is defect, somehow leaky. Also, let's have a look. Here it is, 331 kV, and that's the measurements. And see if I take a random capacitor, the series resistance is very much lower. So that means, well, this one is not capable of handling all this voltage because it's in the primary side, so I need a higher voltage type. So damn it, that means I'm a little bit stuck today. But anyway, I was looking a little bit around in this power supply and having a lot of fun seeking down different components here to look a little bit at, because again we got that's the rectifier snubbing. I see the same kind of capacitors, but obviously here they have been only used for lower voltages. They are actually in parallel here, and those two resistors there are in parallel, so that's between the two windings. They go in like push-pull kind of way, and this is the center, and the center go via a choke and current sense, and then out to the negative. Here's actually a ferrite. It's a little bit difficult to see, and then there's a filter output. Looks like you can put in some extra capacitors here if that is necessary, but it's really, really impressively clean, the output. But that is obviously because they are heavily snubbing everything to be so slow, and they are they're wasting like 50 watts or so in snubbing. I mean, I don't know how many watts that is really, but it's, where else can we lose power in this thing other than those resistors and the resistors here? Oh yeah, I removed this the flat cable, and now I see another transformer, and this is definitely the mains selector, because here I see 115 and the other one is probably 230, right? Also, I want to check out all those resistors, the values, and how hot they get. The fan is wired for 115. So I think those fan wires, they go all this way, and they're connected to the half of the primary side of this transformer, and that means no matter how you select the input voltage, the fan is still gonna run off half of, or 115, right? But the fan is very, very powerful, and there is no temperature controlling that. So, and there is a temperature sensor here, but I guess this is only for shutting down when stuff is too hot. Since this is a professional unit and it's installed where people don't care so much about noise, well, fan is just running at maximum. Classic. Oh yeah, by the way, this is indeed a full bridge primary side, and you can see the 4 driver circuits. So this is like the timing diodes, different diodes and different resistors for turning on and turning off timing. And this is the transformer, the trigger transformer for driving the gates. And this is the classic drive transistor circuit to drive this transformer. And of course, here is our regulator. This is a classic push-pull regulator, by the way. So the rest of the stuff is just normal boring stuff, some op amps and stuff like that. I actually didn't really look so much into what this can do. Of course, it's an analog remote interface, so that is why I definitely expected some op amps and trimmers and stuff like that. You can probably select voltage ranges to do current ranges or whatever it's doing. So yeah, more op amps and yeah, more op amps. It's probably possible to find a schematic as well. Some of the Sorensen converters, they also are rebranded under names, and that means the schematics, they can be sometimes found. Okay, little regulator here. I did I added a little bit of repair coding here. So this is my secret green mix, so I can hide repairs a little bit. But well, of course you're gonna see this anyway, but it's better than nothing. But it's really, really a beautiful design, as you can see. And they're very easy to service. I mean, of course, if you want to resolder on the bottom side, yeah, you need to take out the whole PCB. But that is definitely not what I'm doing here. I'm just soldering from the top, and just, yeah, that's how it's gonna be. I'm sorry, I'm the lazy guy today. So I ended up putting in high voltage 220 picofarad instead of 330. But so that works, and now we don't see any hot capacitors in this area, right? We barely see the stoppers, because at the moment I'm running at 0 volts output. I just had it running at full voltage output, and then this resistor down here, a 390 ohm resistor. I believe this is a load resistor for the output, and obviously that is going to run really, really hot, like 150 Celsius. That is stupid. Do we really need to load the output that much? And here we go. Those two resistors down there, the two on top of each other's, that is the turn on, the inrush current limiter, and that is obviously what this relay is doing, the power on timing. So they run really, really hot the first few seconds at a power on. But all the time when this unit is powered, those resistors run 150 Celsius. I don't know if you, yeah, look at that. And that is just discharge of those capacitors. I mean, that is crazy. They even smell burned. You can smell this burnt resistors, but you know, see, if we look at a distance here, everything else looks healthy. There's just some regulators here. Oh, they're running 50 Celsius. One of them here is running, yeah, 50 Celsius. Just to drive all the analog and digital and all that kind of low voltage stuff. Then you want a heatsink that is that hot, really? But okay, it's at the moment as it stands here at 0 volts, 0 loads, 26 watts of idle. So obviously you're going to see some hot components. All the big bad components here, I don't see any kind of heat or anything. Oi, 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 oi. I can really feel. Yeah. I want to measure the voltage and the resistance. I really would like to calculate how much power is lost here.